Okay, so we've done substitution. Now we've done substitution with a little bit more difficult, and now we're going to be doing substitution with two terms. You say, what do you mean with two terms? Well, a term is separated by addition or subtraction. And so when I look at this equation, I see, first off, when I'm looking for what I want to substitute, I want to try to find an equation where the variable is alone. Well, in the top one here, I see that I have a y by itself. In the bottom one, I don't have an x or a y by itself. But what I mean by two terms is y doesn't just equal x or 2x, it equals x plus 3, which means it has two terms. But that doesn't mean we cannot substitute. I know y equals x plus 3, so in the y problem, or in the second system, I'm going to substitute y with what it equals. So again, I'm going to replace this y with what the y equals. So I'm going to go negative 2x plus y equals 5, and the y we said was x plus 3. Now in this case, it's not a big deal because there's no number, there's no coefficient in front of y, so I don't have to do anything to like distribute, but I still can drop the parentheses and add like terms. For instance, I have 2x, negative 2x plus x, that's going to be negative x plus 3 equals 5. And now I have a two-step equation. I'm going to go ahead and circle the equal sign, circle the variable, underline the coefficient, and double underline the constant. And to solve is 2, 1, 0. So I'm saying, okay, how do I get rid of plus 3? I minus 3. If I do it to one side, I have to do it to the other. 3 minus 3 is 0, and 5 minus 3 is 2. I bring down the negative x, but I'm not done there, right? Because there's that invisible coefficient. Because of that negative sign, I got that visible 1 there. And how do I get rid of times negative 1? I'm going to divide by negative 1. And if I do it to one side, I do it to the other. And so this cancels to 1 or simplifies to 1, and this gives me x equals negative 2. So that's what x equals, but I'm not done, right? So I need to go back and say, okay, well, you can never substitute into the same problem you were solving. So I did not substitute to this problem. I used this to substitute with. So I'm going to use the x that I found and now find out what y is. And I'm going to do that by substituting the x with what it equals. So I have y equals, and I'm going to substitute that x value. That x value was a negative 2. And again, now there's no variables left. I can just simplify. Say negative 2 plus 3 is 1, and so y equals 1. Am I done? No, because the solution to a system of equations is the point where the two lines intersect. It's usually an x and y value. It is the solution. So even though we're not graphing it, it's the solution to a system is still that point where they intersect. So I need to take this and create the solution, which in this case is going to be x before y. And don't make that mistake. Sometimes people solve y first, and they're going to want to put that first. But remember, it's always x then y. And so this is the solution to my system. This is the point where the two lines will intersect. All right, it's the point of both lines. So you go ahead and try this one. All right, I'm assuming you tried this one. So as this one, I look at it and I say, okay, well, on the top equation of the system, I don't have a variable alone. But on the bottom system, I see I have a y alone. It equals this x plus 1. And that's two terms again. That's frustrating, but I still can substitute that in to the equation above. So I'm going to go, okay, in the equation above, where I see that y, I'm going to substitute what it equals. So I'm going to rewrite this equation, 4x plus y equals 6. And I said y equals x plus 1. And again, y doesn't have a coefficient, so really the parentheses are just there to help me make sure I don't lose any signs or anything like that. And now I can say, okay, well, I can add like terms. X plus 4x is going to be 5x plus 1 equals 6. And now I can solve for x. That's going to give me a lollipop, circle the variable, underline the coefficient, double underline the constant. 2, 1, 0 to solve. To get rid of the constant, I'm going to minus 1. Do it to one side, I have to do it to the other. That's 0, and that gives me 5. And I get 5x equals 5, but I'm not done. I got to get rid of the coefficient to do that. I'm going to divide by 5. And 5 divided by 5 is 1, but I don't need it because I have an x. And 5 divided by 5 is 1. So x equals 1. But am I done? No, because I still need to find y. And so again, I can't go back and substitute the original equation. I'm going to go back and use the other equation that I haven't used yet and substitute to that one. In this case, I'm going to be substituting in for x. So I have y equals, because I now know what x is, I can substitute the value of x, which is 1. Now it's a quick simplification. 1 plus 1 is 2, so y equals 2. Am I done? No, the biggest mistake that we see, Mr. Nelson, Ms. Garcia, and myself, is that students will do all this beautiful work, but they'll forget that final step. And that final step is to make the ordered pair that makes this statement true. That's where x is 1 and y is 2. This is the solution to the system of equations. You have to write that. That is the most important part.